This Friday.
This Friday? Yes, we do. We don't have school Monday. Seem to never have school on Monday. Right, exactly. Okay, guys, we have 20 minutes, so let's get through this. I want to have a chance to go over one of the graphing and a couple of the equation parts. Okay, I gave you the formulas. You have to remember that this exponent goes to that factor only. If you want to take the shortcut and divide, if it divides out nicely, that's perfect. If it doesn't, leave it in a fraction. Don't go to an irrational decimal. You can still work it through with a fraction in it. So now, when you need to bring down the exponent, you need a log. Whether you use an ln or you use a log, it works the same way. Now, a couple of you got a little confused with the fraction. Get rid of your denominator. Multiply both sides by the denominator. Just go ahead, I didn't take it. So I multiplied both sides by 3. This side by 3. Now here's where a lot of you mess up. These two are factors. If I multiply 2xy times 2, what do I get? 4xy. I don't get 4, then 2 times x and 2 times y, do I? It's one term. So I multiply any of those factors by 2. If I do this, 1/2 of 12x cubed y, what do I get? 6x cubed y. I multiply one factor by the half. So you multiply this guy, that comes out. This one you have to leave. Some of you still panic with your fractions. Never multiply the log number, whatever, log 2, log 5, log whatever. Don't multiply that. Okay. Everybody okay with this now? Questions? Applications. We did the applications on Friday. Oh, Stephen, don't worry about it, hon. I didn't take attendance yet. This is a bad morning for attendance. I just want to check your work, though. Check your homework. Okay, while you're checking this, let me check this. Okay, again, I gave you the formula. All you had to do was remember that that exponent only goes to that factor, the 2. So divide by 20, and that made your life a little easier. Take the log or the ln of both sides. If you take this in college, most of the college books use strictly ln. You have no disadvantage to using it because ln is with the e, so you never have to worry about using a log. Bring down your exponent. This is why we do this for your power rule. And make sure that you do not divide these two. It's the ln of 500 divided by the ln of 2. Round it to 3 decimals. And this, again, is very checkable. You have an exponential equation. Check it. Stop me if you have any questions. This was a half-life. So the factor was a half. Again, that's all one term there. Now, I did this one out the long way, the correct way. If I divide this, and if you divided this first by 6.58, leave it like this. Even though this is so bad to have a fraction with a decimal in it, it will still process with your logs. You could take the log of both sides of these. It's not proper, but you can still do it. Okay, and you might want to multiply everything out by the 14 because your process was in a cycle of every 14 days. This would absolutely work. It's not the best way, but it does work. And divide by log 1/2. Most of the time, parentheses are very, very tricky. Make sure you put parentheses around your numerator. Order of operations will do that first. And you're going to get a separate parentheses right here for your log. as with this, you'll get a separate parentheses. It works. It's not the best, but it does work. Technically, this is a product, so you separate this into an and. Then you subtract this side log from both sides, and then multiply by 14. It doesn't matter which point you multiply by 14. This again is a little tricky with all the parentheses in it. Everybody okay with this? This was probably the trickier one. This in itself is not a good way to do it, but it does absolutely work. Don't reduce it to a decimal, because we find with the decimal, even if you go 5, 6 places, it's sometimes, depending on where the rounding is, it throws it off. So leave it as an unreduced fraction, and you'll be fine. This one said, when will there be less? And like we did with the exponential, I told you leave the equation, but then when you get to the answer, it's got to be slightly more than your answer. It's got to be a little bit less than 1. So whatever that is, it was at 1. Just say greater than, x is greater than 38.053 days. Good? Okay. I want to jump. Again, I gave you one application, and I gave you the equation. It's been a little while since we pulled all this together, so I didn't want you to panic over having to set it up. Now, remember your basic log. This guy in black here is your basic log. It has a domain from 0 to infinity. It has a range of all real numbers. It has an asymptote of your y-axis, which is x equals 0. Remember it, everything interchanged. And it has a common point of 1, 0. That's your basic log. Yes? I would really like you to graph step by step. I know you can throw the end result into your calculator, but I really would like you to see again what the step by step does. And like when we get to this one, you can absolutely put this one in your calculator first, and then put the +2, and you can still graph each piece. I want you to be able to see the transformations. So when this takes a reflection, it's not next to the x, it's next to the y. The y goes from positive to negative. It's a reflection in your x-axis. As a result, your domain does not change and your range does not change. Here's your new one. It just reflects in the x-axis. And you'll give me the new domain, the new range, and those didn't have any effect. And neither did your asymptote. You're still at the x equals 0. You're still at the 1, 0 point. The second one, probably something more that I would give you. It has a little bit more to it. You're going to start with a basic log, even though it's the e, the ln, it's fine. It works like a power, like a 3 base. You're going to start with your basic log. That's the black one. Your domain and your range. I find it easier if you set this up first. Okay? And like I was saying out there, I would like it step by step. Draw the pieces. Put it in your calc if you're not comfortable. Put that in. That gets you your basic graph. Put this piece in. This, you'll see, there's a horizontal shift to the right. You'll see it move to the right. And I want you to use horizontal shift right 4 units. Now, if it moves to the right, it's going to change your domain. So right away, I'm going to subtract 4. So my new domain is going to be positive, I'm going to add 4. Positive 4 to infinity. My range is not going to be affected because that was all real numbers. My asymptote, however, is being pushed over 4. My asymptote changed. This guy is being pushed over 4. This is a good starting point. So now you know where to go from there. The second part of this, when you do the +2, there's your vertical shift. It has no effect on your domain or your range, because range was all real numbers in this case. So There's your final domain. There's your final asymptote, your final x-intercept. And if you want to solve your x-intercept algebraically, don't forget to set your y to 0, and you can do this. Subtract 2. Flip this to an exponential equation. Log equals exponent, base e, log equals the exponent. E to the negative 2, and add 4. Okay. Solve it algebraically. Make sure you use the right words to describe your transformations. Good? It's not going to be bad. I know we've had this has been going on probably for a month. Can I move the graph down? It's this one. That's your asymptote. If I do, I'll just lose everything though. So it starts with the black one, then it goes to this blue one because it moved 4 over, then it goes to the red one. Moved it up a little bit. Actually, this is not your intercept because we had add 2. So this point became 5, 2 over here, but you have to find your intercept here. Just find your x-intercept. Just throw that in your calculator. And what's nice about this is, when you graph this, if you identify this point 5, 2, when you graph it, you'll see that on your new graph. In NR, whatever this comes out to be for your x-intercept, you'll be able to do x value, stick that in there, just like that. Stick it in there, e to the negative 2 plus 4, and then we'll give you a return of 0. Okay. The rest, we're kind of like separating these logs out. These were expressions, guys. These were expressions. So your log rules, you have 4 of them. A product rule, think about your exponents. When you were multiplying like bases, you added. So a product rule says turn it into an add. A quotient says a subtract. A power, bring the exponent down. And a root rule, if you have a radical, get the radical out of there, get it into an exponent first, and then use your power rule and bring it down. These guys were going backwards. So left to right, just like you would do order of operations, what gave me an add? Oh, a multiply. So I bring one log word out, and I bring out my factors. Reading left to right, I have to subtract. That was a divide. Bring my one log word out. Regardless of what your base is, they all work the same. Divide by x plus 2. And that's all you have to do. These were expressions. They had no equal signs. If you see a number in front, bring it up first. There's your power. You can't bring logs into one until it says log equals log, or log plus log, or log minus log. Get rid of that power up there first. Good? Remember these rules from way back? About a month ago, maybe more. I know, I'm sorry. It's been a crazy marking period so far. No, we just used our last one. Yeah. Last year they didn't apply in time, so hopefully this year they'll be a little smarter in applying time. Otherwise they'll take it off of our spring break again. Okay. Everybody okay with this? Order of operation says inside the parentheses first. So this was a product, so set those up as a product. Then you've got to subtract. Don't forget to bring up your exponents. These we did the opposite, we expanded. So get rid of your add first, put it in, get rid of your multiply first, put it into an add, your quotient, put it into a subtract. Here's your add in here, separate that, and bring down that exponent. Now, on the test, you're going to be looking at equations. What I would do is make sure you go back to the sheet that we did with equations on it. So let me just run through an equation or two real fast. See if I can just run through an equation or two. Okay. Okay, what would you do for this? Guys, I'm trying to help you for your test tomorrow. In 3 minutes. What would you do for this to solve this equation? Solve it. You can't because it's attached to a log. So we put a line on the equal sign, and we see logs all over the place. If you get it to say log equals log, you can take the logs away. So when were you subtracting your exponents? What were you doing? Dividing. So pull out your log, set it up as a divide. Ah, now you have log equals log, right? So what can you do now? Cancel out your logs. So can you solve this? We would cross multiply, and you would solve. And then, what would you do? You would go back and check to make sure that you didn't take a log of a negative or a 0. I have no idea if this is going to work out. I just made this up. But I wanted you to get down to here. Down to here, you can solve this, right? And we can solve the whole thing, guys. And divide by 3. Would that work in here? No. Why not? You can't take the log of a negative number. It's not a fraction. Okay, I have 3 minutes, guys. Let me give you another example. I'm not going to feel bad for anybody tomorrow when you can't do this. Girls. Okay. Let's make this different. What do I do here? Put a line down the equal sign. Ah, when you added, you were multiplying. You get this into one log. Now, you only have logs on one side. You can't put a log on the other side. You can't get rid of it. You have to flip this to an exponential equation. God bless. Log equals exponent. What's the base of my log? E. What's the base of this log? 10. E to the third equals 5x. Okay, if you have logs on one side, get it down to a log equals something and flip it. Okay, one more. One more. Guys. How do I solve this? You have to use a log to bring down the exponent, but before I do that, what do I have to do? Subtract 5. Now I can take the log or the ln of both sides. It doesn't matter. Bring down your exponent. Those are your 3 types of log equations.